I wanted to do one example that uses the central limit theorem. Normally in class I would go on a math major type tirade about the central limit theorem, but I'm going to just stick to an example here. So here's the example. The height of giraffes is normally distributed with mean equal to 15.8 feet and standard deviation equal to 2.3 feet. So here's the question. Part A, if a giraffe is selected, find the probability it is taller than 17 feet. Okay, now this is a problem, the same kind of problem that we did before, and to do this on the calculator, I'm going to enter normal CDF. The low x value is 17. It goes on forever and ever and ever, so the high x value is 99999. It's usually 6 nines. The mean is 15.8, and the standard deviation is 2.3. On the calculator, I'm going to normal CDF, and there's my stat wizard is on. So the low x is 17, the high x is 999999. The mean is 15.8, and the standard deviation is 2.3. And when I hit the magic button, about 0.301 to 3 decimal places. We've done examples like that before, but now I'm going to do an example in which I'm going to apply the central limit theorem. So part B of this question, if a group of 22 giraffes is selected, find the probability their mean height is more than 17 feet. So because we have a group of 22 giraffes instead of a single giraffe, this is where we're going to use the central limit theorem. So let me just remind myself what the mean and standard deviation here. It was the mean was 15.8 and the standard deviation was 2.3. Was it 15.8? The standard deviation was 2.3. According to the central limit theorem, this probability is normal CDF. We still go from the low x to the high x. The central limit theorem says the sample means is the same as the population mean, which is 15.8. But here's the issue here. The standard deviation for the sample means is the population standard deviation divided by the square root of the sample size. So for the standard deviation, we go 2.3, but divide it by the square root of 22. And that part right there is where we're using the central limit theorem. On the calculator, I'm going to a normal CDF. Everything is still the same as before, except the standard deviation 2.3 is divided by the square root of 22. And this time the calculator spits out 0.007. Note that it is far more unlikely that a sample of 22 giraffes is an outlier than the probability that an individual giraffe was an outlier.